Good day, students. Welcome to this revision session for Chemistry ASA level. Today I'm going to look at question 4E, which came in 2002, paper 2 or paper 21. This question was based on calculating enthalpy change. It was question 4E. It was a question which was asking people to calculate the enthalpy change for the hydrolysis of urea. Okay, enthalpy change for the hydrolysis of urea, the equation is shown on the board. Okay, so usually when they want to ask you about enthalpy changes calculation, they give you some information. Okay, so whenever you are given information, it guides you as to how you are going to draw your energy cycle. Okay, and also the backbone also for this calculation is Hess law. You remember Hess law is a law that talks about the enthalpy change for a chemical reaction is independent of the route taken by the reaction. So we want to look at what sort of information we're given and how can we use that information to find the enthalpy change for hydration. Okay, so the question was saying use the data to calculate the enthalpy change for the hydrolysis of urea. So this one is the delta H hydration for urea. That's what we want to calculate. But we were given enthalpy change of formation, enthalpy change of formation of water, enthalpy change of formation of urea, enthalpy change of formation of carbon dioxide, enthalpy change of formation of ammonia. The moment you get such information, it means you are supposed to write down the elements down here, and then you put arrows to indicate or to illustrate the formation of the compounds above. So if I want to form water, I would need hydrogen and oxygen. Okay, that is what I could use if I want to actually form water. Okay, so hydrogen and oxygen I've actually catered for water. Okay, that's enthalpy change formation for water. Okay, so I can call it delta H1. Okay, but if I want to form urea, I would need hydrogen, I'll need oxygen, but I also need carbon and nitrogen. So I write carbon and nitrogen here. Okay, and also if I want to form carbon dioxide, I need oxygen and carbon. They're already down here. If I want to form ammonia, there is nitrogen and hydrogen. All these are already down. Okay, once I have done that, I can put a square I can put them in a box like that. Okay, so in order to form urea, okay, I would need carbon, I would need oxygen, I would need nitrogen and hydrogen. In order to form carbon dioxide, I would need carbon and oxygen, so I put an arrow going up. In order to form ammonia, I need nitrogen and hydrogen, so I put an arrow going up. Okay, so this one I am going to call it delta H2. This one I'm going to call it delta H3. Okay, right. One point which you must remember is once there's a coefficient here, okay, it means whatever delta delta H value you are given, you're supposed to multiply it by 2. All right. So if I'm going to call this one, I'm going to call this one 2 multiplied by delta H4. Okay. So two things. First of all, we need to take note. Okay, there is no coefficient here, so we don't multiply. There is no coefficient there, we don't multiply. There is no coefficient here, we don't multiply. But there is a coefficient here, so we have to multiply. Okay, if we don't do that, we get our answer wrong because all our delta H values are kilojoules per mole. So if you are saying enthalpy change of formation of ammonia is going to be for 1 mole, here we have 2 moles. Okay, now we are now given values in the question. Enthalpy change formation of water is given as minus 287. Okay, enthalpy change formation of urea is given as minus 320. Enthalpy change formation of carbon dioxide is given as minus 414.5. Enthalpy change formation of ammonia is given as 81. So it's 2, okay, multiplied by minus 81. Okay, that is very important because we have 2 moles there. Okay, we are done with our energy cycle and we now need to calculate delta H hydration. Okay, so using Hess law, we are saying the enthalpy change, if I were to move from this state to that state is similar if I were to go via this route. So I could call route 1 is equivalent to route 2 according to Hess law. I can go straight, which is delta H hydration for urea, or I can pass through the enthalpy changes of formation, and then here I go down and that side I go up. According to Hess law, this is the same thing. Okay, so we can translate our equation. Going straight, delta H hydration, which is route 1, is equivalent to go down and up. Okay, and then the other thing is, if I am going down, okay, if I go down, right, this delta H was 287 going up. If I go down, I have to change the sign because I'm opposing. 2 minus 287 is going up. So if I go down, I have to change the sign. So it becomes 287, or you can say plus 287. The same applies. Delta H2 minus 320, delta H formation of urea is going up. Going down, you have to make it a plus sign. Okay, that is very, very important. Okay, right. And then now here, this value, I'm going up. Okay, so I'm going in the direction of this value. So I'm not going to change the sign. And also here, I'm going in the direction of this value. So I am not going to oppose. Okay, if we're going down, we're going to change the sign. But here, we are going up. On this side, we're going down. Why are we going down? Because we want to move from this side and then we go to that side. Okay, it's like almost we have some form of a vector. Okay, where we have this and then we are saying we want to, okay, then move, okay, like that. Okay, and then we go in that way. This is what we are talking about. So when we are going down like this, we change the vector. Okay, so we are saying according to Hess law, if we saying route 1 going straight is going to be equal to route 2, which we are going to take it like that. That's what we are doing here. Okay, so here we are going to simply say minus, okay, 414.5, okay, and we are also going to say minus 2 times 81. Okay, right. We've put the minus sign here outside the bracket. And then if you do your calculation here, you are going to get your answer as plus, okay, 31 kilojoules per mole, okay? Never leave this plus sign in your calculation because the examiner will mark you wrong. Okay, that is very, very important. Okay, just as a quick recap, you need to take note, okay, of the sign depending on whether you are opposing this arrow or not. If you are opposing the arrow, you change the sign. Okay, if you are moving in the direction of the arrow, don't change the sign. Point number 1. Point number 2, also take note of the coefficient. If there is a coefficient, you need to change. Thank you. If you like this video, please subscribe, share with your friends for calculation of enthalpy changes, and they'll use it to revise for their exams. Thank you.